Okay, so what is given is they gave us silver, well, they gave us Ag 107. First thing I always do is what element am I dealing with? So find Ag, put your finger on it on the periodic table, everybody. Look at your neighbor. If they have their finger on silver, you can give them a smiley face. Yeah, like say, hey, have a smiley face, Megan. But their finger has to be on silver. Yeah, I mean, I guess you could deny it if you want, basically. Okay, so I'm going to write silver. Okay, back up front here, everybody. Okay, so silver, and then you always do dash the mass. Okay, keep in mind we label isotopes by how heavy they are. Okay, the number that comes with an isotope shows us how heavy it is. Okay, so I can automatically take that number and put it as the mass number. Right, the mass number is the number associated with the name or the symbol. Okay, I'm going to change colors as I go to kind of help see how these things are connected a little bit, if that helps you. Okay, all right, the other thing, since we found it on the periodic table, is that tells us its atomic number. Yep, 47. So the atomic number is found. I'm just going to put PT. Look at the periodic table. Okay, don't go to physical therapy. Look at the periodic table. Okay, I mean, you should go to your physical therapy, but it's not going to help you. Okay. Okay, then 2 for 1. Atomic number is proton number. It's just the fancy name for it. So this is also 47. Okay, so atomic number is the proton number. All right, I'm going to go to, I guess we'll just keep going down the row. So electrons, okay? So the association with electrons is electrons are connected to the protons and the charge. Okay, you can think of it like a balance. Protons and electrons equal the charge in terms of positives and negatives. So if you like an equation, once again, there's different ways of thinking about it, but you could think that protons minus electrons will equal whatever that says charge right there, whatever the charge of the atom is. Because protons are positive, electrons are negative, so the ratio of the two of them give you the charge. Okay? Yeah, Sam?
What does that word say up there?
Charge. In blue?
Yeah.
Charge. So P minus E equals charge. Yes, Boston?
What is the balloon for?
The up top? Oh, the balloon. It was from general chemistry thing we did today. So it's just hanging out with us now. Yeah, it's a pretty good balloon though, I thought. Okay, so in this case, there's no charge. Charges would be shown right here on the symbol. If no charge is shown, then the charge is 0 or neutral, which means our electrons are going to be the same as our protons. So this is also going to, not 17, I'm at 47. Okay, so because they're the same, because it's neutral, they're the same, but that's not like a guarantee thing. Okay, right, so like this arrow means these two are always the same. Protons and electrons don't have to be the same. Okay? All right, neutrons, their big thing is they make atoms heavier or lighter. So you want to look at the mass. So our connecting piece here, let's go with white, okay, is that protons plus neutrons will equal the mass. So we're going to do the opposite. Since we have the mass, we can minus the protons, and I can get my neutrons. So 107 minus 47 for my neutrons. Now, just to make sure we understand, do electrons have mass? Yes, but it's so small we kind of ignore their mass. Okay? Yeah. Yeah, we just like, meh, we'll deal with it later. Okay, and then our final column here, valence electron. The pattern for that is you look at the columns on the periodic table, skipping the main group section. Okay, so we're looking at silver, and oh no, it's not in the main group section. So for today, we're going to write to be determined.
All right.
But if you want to see an example, chlorine, find chlorine on the periodic table. The reason why its valence is 7 is because if you count the columns 1, 2, skip the middle section, it's in column 7. You can kind of look at my numbers up top, but the ones over here just take away the 1 in front, and then it matches. So 3, 4, 5, 6, 7, 8. I thought I saw a hand somewhere. Got it. Did we clear it up, Michael? Okay. Yeah, Mason.
So just to clarify, all of the numbers on the top minus the number in front is the number of valence electrons. So like for nitrogen it's 5.
Correct.
And then, okay.
Yep. And then like hydrogen's 1.
Yeah, just not in the...
Yep. And then the whole middle section's just weird, so we're going to skip it for now.
Okay.
And also helium.
Oh, yes, thank you. We did point that out at the end last time. Helium's the exception. It only has 2. So, questions before I show you one more real quick? Okay, let's go through this one. Okay? Stop me if you don't see where something comes from. I'll go a little bit faster, but don't hesitate to ask. Okay? Mason, have a smiley face for reminding us of that. Okay, so magnesium, once again, my best friend is I always go to the periodic table first. Okay, so we should know because we memorized it. Mg is magnesium. So let's write its name, dash the mass, and then we are going to put the charge on the name as well. So you make a little superscript of a +2. Because once again, if there's nothing shown, we assume neutral. So if it's not neutral, you need to show it. Okay? On the periodic table, magnesium has an atomic number of 12. Which is going to be the same as my proton number. Mass number was given in the symbol, so put that as 25. Now, electron number, we have a +2 charge here. So the way my brain thinks about it is, hey, that means I have more protons, 2 more of them, than I have electrons. So that means I must have 10 electrons. If I'm positively charged, I need more of my positives than my negatives. You could also think of it as like 12 minus what will equal a +2 value. Right? That's if you like to think of it like an equation. I like to think of it just like a balance of a scale. So, okay, neutrons we're going to minus from our mass. So we got 13 neutrons. Charge was shown on our symbol, so we'll put a +2. And then magnesium is in column 2, and so it has 2 valence electrons. Questions before I have you try some? Yeah?
Wait, why is the number of electrons 10?
So we have a +2 charge, right? So that means you have 2 more positive things, which are protons. Then you do negative things that are electrons. So since my protons right here, so I have 12 positives, so I must have 10 negatives to equal +2. Does that make a little more sense, Geneva? So think of, they're not, like you don't write negative, but you could think electrons are always negative, so 12 minus 10 is what gives me +2. And I'll be honest, the electrons are the trickiest of all the pieces to find. So have a smiley face for asking that. Annie?
For the mass number on magnesium, is it like, do you round to get 25? Because on the 4, and then, but then for silver, if it's rounding, it will become 108.
Good point. Okay, everyone pause for a second. I know I told you to start trying them. Annie asked a really good question. Everyone pause really quick. Freeze. Freeze, look here really quick. Annie brought up a really good point that I should emphasize. So the periodic table has a mass, right? So magnesium on the periodic table is 24.305. Okay, can someone remind us what, that's not the mass number. It's close and related, but it's not it. What is it, Camille?
It's the average, so it's like all of the isotopes combined.
Yes, and so think of it, when you take an average, right, you could have 22, 23, 26, 27, and then the average to be 24. And in our case, what we're looking at is just isotope 25.
Okay.
So you actually never, and this is actually something sometimes in like younger science classes to make life simple, they tell you to round that number, which like has truth because you're finding the most common isotope. But we're going to look at what specific isotope are we dealing with. And in this case, it's isotope magnesium 25.
Okay.
Does that make sense?
Yeah.
Okay, have a smiley face. Great question. Mason.
So you said magnesium 25. Is the 25 from the mass number?
Yep.
Okay.
Yeah, we talk about isotopes by how heavy they are.
Yes. Okay.
So. Yep. Okay. Abby.
I was just wondering how you figure out the 25, because it's not the average, so like. you just-
So you couldn't just, there has to be something given.
Okay.
Either they're going to give it to you, or maybe they'll give you protons and neutrons. You can add them together.
Oh.
But there's no way, like if you just had a sample of magnesium, there'd be no way of knowing which isotope it is just by looking at it. So yeah, great question. That was my face for that. Alex, did you have something?
This can be when people are working on their own time.
Okay. All right, I'm going to set a timer. We'll shoot for 5 minutes on these three. Compare with your table, right? Because it's good to like, you might catch your own mistakes before we check it together. Or at least if you're wrong, you'll feel united in it, which always feels better. Okay? And then we'll check this in 5 minutes for some smiley faces for everybody, okay? Actually, let's go 4 minutes.
Is there any element where the atomic mass does like the one where it's like this one is but there's like some that are less heavy than the other ones?
It could, and we'll, the second part of our lesson today is the experimental proof of isotopes. So we'll look at like graphs that show all the different isotopes, yes, that's mass spectrometer. So that will kind of, I did see some examples of like, perhaps 9 isotopes. It is a weighted average, so whichever one is most abundant, most likely, pull it out.
Not what I said.
It should be close to what's on there, but I could pull out one of the.
Don't do that again, bud.
Right, that's like.
Yeah, but you know the averages aren't approximately.
I think growing, we'll look at that today, where like, it actually rounds, I don't wanna give it away, because we're gonna talk about it later.
Alright,
When I say this. But no, I would, yes, there'd be some where if you round it, it may not be the most common because of how the average is. You just want to look it out. So, does that make sense? Hey, just to help me visually, when you are done, if you'll turn your light to white for me, just so I can kind of visually see where everyone's at.
Why did those cause a drop? This freaking guy.
Oh, wait, no, this is not.
Good job.
We've always been
So that's kind of what it is.
Sodium.
So this number is the weighted average of all the magnets that are magnets.
That's how old I am.
I'll try to be more creative.
We're looking at just this isotope. If you bring up this number, then you're only taking into account the most common isotope. So don't ever look here, look
I really like the PRI table. I'm with your buds open.
Okay.
And
11, 28, 11,
pretty good.
Did you get the same thing?
I'm there.
Yeah, okay, yeah. Does that make sense?
No.
Said it like just, I
23 is the max.
don't know how that happens. Yeah.
That's
It's like,
fun.
Yeah, that's 23.
You found it.
There's actually,
Hey, good job.
This freaking guy.
But someone last year did. I'd like a minor
Because it's one.
Oh,
Yeah, I
I don't have that, so just sign out.
Well, how do we know you're right? Because
You look at the charge. Look at the charge. Plus my charge.
I thought.
Then you have 11 protons.
Get off and get back. It's 12, it's 12, it's 12. Yeah. Yes, one trick out. I missed this, bro. I had 22 instead of 12. Okay. That was like, I don't know how you figure out the charge on
You missed one.
Yeah, I know.
If you're done, turn your light to white.
So it's 3.
You're gonna feel where we're at.
Let's do 3 more.
And then we'll check our answers here in a few seconds.
What idea?
Okay. All right, we'll get us 30 seconds, and then we'll check our answers.
That makes sense, actually. I should have done that one before. Actually, all this stuff.
What is that?
Stay still.
Now, if you are a big promoter, I'm not saying now because we're going to move on, but moving forward, if we ever do a practice problem and you finish, and there's time to spare, and you're just like, I don't have any time in my life to get things done, you are allowed during like work time to quickly pull out your homework and like start on it, but then you have to make sure you put it away when we start moving forward again in the notes. Otherwise you're going to be in trouble. So don't pull it out now because we are going to start moving forward. But that's something like I'm okay using time wisely, right? Like if you finish your practice problems and you're waiting. So, okay, check your answers with mine. You can have a smiley face for every row that is correct. Not every box. Okay, check your answers. Let me know if you have a question. Sorry, that one's really pretty right here.
Are we supposed to say the charge just for this column?
Yes, if you didn't, you're okay this time, but do put the charge on the name. Good question, Lincoln. You can. It's not against the rules, but you don't have to. I normally don't because I just am lazy. But you can if you want to.
Yeah, why is there the fifth atomic number under phosphorus than the other one?
Which one are you looking at, Abby?
On your example, it says 31 and 15. That's the atomic number, and I was wondering why you put that on there and not any of the other ones.
Oh, I wrote these last period, and someone brought up what Lincoln brought up. So I'll say this louder. So this one right here, everybody. Where'd my little highlighter go?
I wrote 17.
Am I like double filming right now?
I wrote 5 here.
I don't know what's going on here. Okay, so right here, everyone see that? You can, and you might see the atomic number written on the bottom of the symbol, but it's not required. And most of the time I leave it off myself. But to me it's kind of like, because phosphorus will always be 15, 15 will always be phosphorus. So if you don't have it, you don't need to mark yourself wrong on it. So any questions on these 3? You got one wrong, you're not sure why. Feel all right with that? Okay. All right, let's dive a little deeper into what Annie brought up about our atomic mass. Okay. So keep in mind in general as we go through this class, honestly in any science class, all units are arbitrary, right? Like humans just created units. We decided this long shall be a minute. This long shall be a second, right? Like we use them scientifically, but like all units have been decided by humans so we can measure things. Is that enough?
Yeah.
It's like I heard a teeny tiny tap. So what scientists did when they were establishing a unit for atoms is they used carbon-12 as the standard. Okay, and it leads into that, yes. So carbon-12 was chosen as the standard for what is called the atomic mass unit. Okay, an atomic mass unit, the only time you're going to see AMU is when you're measuring atoms because it's a teeny tiny amount, which is what atoms are. Outside of that, we would never measure with it. But it's equal to 1/12 of a carbon atom. Okay, these are the detailed breakdowns for proton, neutron, and electron of how heavy they are. Right, so I said it's about 1, it's about 0.005. But that is like more of their decimals that they do have. So as we're looking at it and we get to the atomic mass is the weighted average of all the isotopes that exist for that element. Okay, so imagine if I had a bucket of carbon atoms. I could pull one out and it might be carbon-12. I could pull another one out, it might be carbon-13. But they aren't all created equally. Some are going to be way more likely that I pull out than others. Some isotopes are very, very rare, like less than 1% you would find. Okay, so keep in mind, it's not a true average, it's a weighted average. That's the missing space there that's covered by my bar. It's in a very opportune place right there. Okay, so a weighted average is just like your grade in this class, right? Like I said, not all points are created equal, right? What's the thing that affects your grade the most? Test, right? So your test score is going to reflect most closely your grade, right? Your participation grade isn't going to maybe show what your true grade is because of the other categories, okay? So the equation that scientists use for any weighted average is you take the mass of an isotope. Okay, I'm going to change that here so we can see it a little bit better. Okay, so this is like one isotope. So let's say that's carbon-12. We do the mass of carbon-12 times what its percent is. Okay, then we add that to the second isotope, so carbon-13. And then if there's 3 isotopes, you would add all them, however many isotopes you have, and then to get it out of a percentage, we divide by 100. Now, mathematically speaking, if you understand percentages, you could just change them to decimals first and not divide by 100. That would also work, okay? Now, there is a chance, because there's always a chance, that you could actually have to perform this calculation on the AP test. Most often, though, what I see is it's actually more of an understanding of what the number tells us. So on your homework, you'll see a little bit of both. I will have you try the equation once just to get familiar with it. But more importantly is like understanding what this number tells us. Yeah, Michael?
Do they have a calculator on the test?
Yes, you do get a calculator on the test. Yep. So try this with your table group. I'm going to give you 2 minutes and then we'll call on some people to share. Okay? Ready, set, go.
Literally, like sometimes I find every single percentage for every single isotope.
Spend your entire life trying to create like
So that's has different isotopes than the number that's not white, like the atomic number. So we're turning in the next stage, so most of one. So really, it's the same way as this just turns off all the lights. Oh, I see.
Wait, stop. I said, did you not read without doing any? Yeah.
Just point it out.
But that's doing math. So don't do math. Top of your table. Top of your table. One thing too we need to work on is when I say to justify, you need to have a full complete sentence. Okay, otherwise you get 0 points. What? And I also have more colors than you guys. And you can make it like dance.
Wait, keep it.
I'll leave it till we're done with this problem. Did you answer it yet? Okay, now answer the problem. Yes, this one. Well, kind
Closest to 73 or 81. Just by your answer.
as long as we're
Because they're both about 50. Yeah. 80s in the middle. Combined, they equal 100.
oh yeah, 79.
okay. All right, it's looking. Give me a pencil drop if you're done. More dramatic, the better. Keep holding if you're like, I'm finishing my sentence. Okay. Anyone raise a hand willing to share their table's discussion? No, we haven't heard from yet. Go ahead, Amanda.
We just said that since they're both close to 50,
that won't really affect it that much. And now we're just looking at the numbers, so between 80 and 79 is 80, or 81 and 79 would be 80.
Perfect. Yep, so the correct answer, you should have picked 80, and his justification was great. Since they're weighted equally, it actually will fall in the middle of the two. Now, just for scenario's sake, what if I were to say that this one was like 80 and this one was 20? Then what would we predict? Good, then it's going to be shifted closer to 79. So, to me, knowing how to do the calculation is helpful, but more importantly, like, what does this number tell us? Okay? Yeah, Geneva.
What if it was more like 60 and 40? Would it still like be in the middle? Or
Probably, yeah. You would guess like maybe it's going to be on like the low end of 80, right? Instead of like right, or like maybe 79.5 or something, you know? So, okay, questions on atomic mass or any parts of our atom? Yeah, Michael?
Why if there's 80 instead of 20%? Why would it be 79?
So bromine 79 is the isotope. And if it had an 80% abundance, then that means when you do the math, it's going to pull the average closer to it. Does that make sense? So it only falls right in the middle because it's equally divided. Does that make sense? Yeah. Tommy?
If both 79 and 81 were at 25, but then 80 be it?
Are you saying if there was an isotope, another isotope, 80? Because technically there isn't even an isotope 80 that exists, which is interesting because it ends up being our average mass.
Wait, really? Why?
So, but yeah, then you would have some other isotope that either pulls it one way or right in the middle. So, okay, have a smiley face, Landon. I forgot to say that. Help yourself. All right, objective number 2 for today is we're going to learn about, we're going to learn about this thing called mass spectroscopy or mass spectrometry. And the goal is being able to identify unknown elements from them, okay? So the way we're going to go about learning or starting to introduce you is something that we'll do every so often in this class. As I mentioned, my goal as a teacher is not to just tell you things or teach you things, but to involve you in the learning process so you truly can learn. So what we're going to do is I've given you some models about a mass spec. You're going to use those models and see what you can conclude on your own, right? Without me just telling it to you, because that's when things stick, is when you see the pattern, right? That's when you're like, oh, I see it, okay? So the way this is formatted, once again, we'll see them again throughout our notes, is it's called a POGL activity. POGL, oh, what are you doing? You're in the way. Go away, video. Let me come over here. Oh, that's not your class. Hold on, scroll down. Here it is. Okay, so POGL stands for Process-Oriented Guided Inquiry Learning. Big mouthful. The basic idea is I give you some information. Through your own looking and discussing, you can draw the conclusions versus me just telling it to you. Okay? Now, when we work on POGLs, it is a team activity because we're going to be united as we learn together. Okay? So each person at your table is going to have a different role. So everyone look at your element box, and you have a little sticker on there. Find what color you are today. And see their color? If you're a table of 3, you'll just have to fill in the missing job. So, okay, raise your hand if you are the black dot. Where's my black dots today? Okay, and these will change like each time we do them, so don't feel like you're going to be stuck with this job for your whole life, okay? All right, black dots, you are the designated reader of the day, meaning you read the given information and you read the questions out loud. Helps the group stay together when someone is reading out loud as you go, okay? All right, pink dots, where are you at? Raise your hand, pink dots. Pink dots, you can take that job? Who's going to take it? Thanks, Camille. Okay, pink dot, you are what I call the first to speak, okay? Give me your attention, everybody. So after the reader has read the question, then the pink dot will be the one to either answer their thoughts on it, or they can ask someone else's their thought. The goal as the pink dot, your job is to divide up the talking. Okay, so don't answer them all yourself, but be like, hey, what do you think, Landon? And then, kind of rotate through the questions to give everyone a chance to speak. Because I know naturally there's some people who will automatically give every answer, and there's others who actually have probably really great things to say, but they're just not going to shout it out. But if you give them a chance, there's an opportunity there. Okay? Questions if your job is the pink dot. Okay, white dot, where are you at? Okay, you're the person when I come around after you get done with Model 1 that I'm going to talk to make sure we don't have any misconceptions before we move forward. Okay, so there's 2 models we're looking at. Stop after Model 1. There's 5 questions associated with it, and pass off with me. Okay, and then blue dots, last one. You guys are the designated question asker, meaning if your group gets stuck, it goes through you to me. Okay? Now, after you get passed off with me, jobs rotate. Okay, so one person will have Model 1, and then you'll switch jobs for Model 2. It's a little bit shorter, but once again, it'll change every class period. So, okay, questions on your jobs? Okay, so black dot, the thing I want you to start off by reading is this little header above Model 1. Concur?
Concur.
All right, ready, begin.
When John Dalton proposed the first formal atomic theory, he stated that atoms of the same element were isotopes. Today we know that atoms of any element contain several different isotopes, or atoms that differ in mass. Mass spectroscopy is the principal technique used to study isotopes. It is used to count and rate atoms in the sample, but just not in the traditional sense. You have Model 1, as you can see.
Can you read
Ionization, magnesium atoms, mixture of isotopes, magnesium ions, mixture of isotopes, acceleration, deflection, plus negative, the vacuum pump. Can you read the picture? The text.
Can you read the Pogo?
Total time.
Oh, thank you.
According to Model 1, what 4 processes occur inside a mass spectrometer?
Alright, so I think that
This guy's looking at Sorry. Dude.
alright.
Lena, let's look at the group.
Alright, so I think Landon is getting kicked out.
What'd you write? Because we actually don't know.
Ionization, acceleration, deflection, and detection.
Yeah, just doesn't say that.
Ooh, I'm
And then there's 5 questions for Model 1, so turn the page. 5 questions for Model 1. So just stop before you go to Model 2.
What are the 4 things it does?
It's labeled.
Ionization.
I'll look you up.
Alright, so it looks to me, guys, that it accelerates the isotopes, and then the ones that have it ionizes them, and then the magnesium ions mixture of isotopes get into the deflection zone, where there's a positive.
I'll answer later. Yes. That's a good question.
No, could you talk like don't have a problem speaking? Sorry.
After answering question 5, raise your hand, I'll come down and stop.
Okay, who's fastest enough?
Why is he reading?
He ends up reading his explain.
Hey, Judah. Do you want to pass it off to someone?
Alright, guys, we're doing this thing. We're doing number 3.
Have you done this first? Consider where the sample is. Consider where the sample is introduced into the mass spectrometer. Which one of the processes is one of the first processes? I agree, exactly.
This guy gives great insight.
All in a day's work.
What's also very checking electromagnetic field supposed to the mixture based on the mass of charge as deflection.
The top is deflected. Why are you going out of order? Wait, 4, 3, 1, 2.
Ions collide from the metal to the iron, producing current testing the speed that comes from protection.
That's the back.
Wait, what's the first? Detection. Detection.
Yes.
Yeah, during the deflection process.
Number 4, I said that it depends.
Wow, you get the question.
A sample is injected into the mass spectrometer using 2 atoms or molecules having positive or negative charge. So if I answer at least now Lincoln says something, and then Lincoln landed.
I'm rethinking because they all have the same Oh wait, no.
Because they're different isotopes, they don't have.
Yes, Leadoff.
So, what does this step do?
Ionization.
Sample.
Yep. What would cause something to become positively charged? Yep. So think the sample's not a single magnesium atom. Think it's like a bundle of magnesium, right? It's like a whole bunch of atoms. Then they get turned into a whole bunch of magnesium ions that are all positive.
So why does this one get attracted to it? This one to the plus?
He's weak. He's not heavy. No, he is heavy.
The only thing different is the flawless.
This guy's too heavy. This guy's not heavy enough.
Because even though like it's almost like it's not so much it's getting attracted here. It's just so heavy it's not getting attracted over there. Does that make sense? What is a mass spectrometer?
What was the question?
When the ions become
Okay, awesome. Go ahead, rotate jobs and look at model 2. No, don't move the stickers, just say which one. Ready? Okay, talk about mass
Link through the acceleration.
What is the mass number of bonds called an isotope?
According to model 1, what causes the sample mixture to become separated?
What's ionization?
Yeah, sorry.
Do you have an addiction to fluctuation?
So did you ever do like
I'll be back.
Did she say you don't have to do this? Did she say you
instead of the 9s, or
So you don't do the same thing.
I literally turned right and put my smileys again. Oh, bro, I actually do appreciate it very much. You're such a great guy.
So like if there was a zero.
Okay, in this sentence, what is mass spectrum? What's I put in just magnesium. What do I get out? The different isotopes this is actually how scientists prove that isotopes exist. Separate them. Okay, change jobs and go to model 2. Okay,
You're supposed to swap though.
Dude, I'll be the first to speak this time.
I'll be the I'm whatever. What?
We're ready. Count down. There's a countdown and talk slow.
We're done. Bad. I mean, there's a window right there. We can just
what are they? What's different about them? This is magnesium. Okay, good. Change jobs and look at model 2. Okay, ready? Pass off. Give me a sentence. What is the point of mass spectrum? What do we call atoms that have different weights? Okay, change jobs. Go to model
Never mind. Someone just like kept their thumbs up for my arm's stuck. You do it for
I just have magnesium.